Hello and welcome to another maths video. Here is about exponential functions. Okay, these are functions on the form a times b to the power of x, where b, the base, is positive. This base must be a positive real. X is the exponent. The variable is the exponent. That's why it's called exponential function. When you see the exponent variable is an exponential function, there are two types of exponential functions. These are the two types. B more than 1, the base more than 1, that's the first type, when the base is more than 1. The second type, when the base is between 0 and 1. The first one is called growth, because when the base is more than 1. The second one is called decay. So here are two examples, one for the growth, okay, and another one for the decay. We call it growth because the base 2 verify the condition b equals 2 is more than 1, and the second one b equal 0.5 half. Okay, so these two verifies the condition is more than 1, that's why it's growth, and this one is 0.5 more between 0 and 1, that's why it's a decay. The constant a can be any real number different than 0. In this case I took a equals 1. Okay, so I'm going to show you the graphs for both functions. For the growth, you get an increasing function. That's why it's called the growth, because there is an increasement. And for the decay, we have a decreasing graph, and that's why it's called decay, exponential decay. Now, the increasement. You need to know that increasement means that when x increases, okay, when the values of x increases, which is moving to the right, y increases. The values of y of the function g of x increase, and that's why you see the shape of the graph going up. For the decreasing function, as x, if you take 2 points from the graph, as x increases, as x goes to the right, takes values bigger, y decreases, takes less values, goes down, and that's why you see the graph for decreasing function going down like this. Okay, so this is what does mean increasing and decreasing functions. Now the domain. These two functions, or all exponential functions, all of them, decay or growth, they have a domain or real numbers from minus infinity plus infinity. You can calculate and find any point for any value of x on the values of the x-axis, all the values. Okay, so any value, any point has a value x between minus infinity plus infinity. That's why the domain is a real number. Same for decay. All along the x-axis, any x has an image by the function, and therefore there is a point which is x. The range, when a is positive, which are these two cases, a equals 1 or any positive, the range for this one is all negative real numbers, which is the interval from 0 to plus infinity, because the y for any point on the graph is positive. Any point on the graph has a y coordinate positive. Take it anywhere on the graph and look at the y, it's more than 0. Okay, and that happens as well for the decay. It's true that the y is decreasing, but with always positive values, and it doesn't take the value 0. Y is more than 0 without taking the value 0. This is the range on the y-axis, and y never takes the value 0. We can draw these functions manually, okay, by dressing a table of values in these both cases. So we have this table for both of them. You can put values for x here. I've chosen these values. Okay, these are like ideal values to use. And then you substitute in the function. I advise you to use the calculator. Okay, there is a table feature in the calculator. You get the values for the y using this calculator. These are the values of y after using this calculator, and then we plot these points and we graph. Okay, x and y, we plot all of them point by point, and then we join and graph. This is the first point, -2, 0.1 for the y. Okay, and the second point x negative 1, and the y 0.3 approximately, okay, and the next point 0, 1, x 0, y 1. That's your point. X is 0, y is 1. Okay. Next point 1 and 3, 1 on the x and 3 on the y. 1, 2, and then extend your axis, you get 3. That's your point. Okay. That's it. You join them and you get your graph. Just join them. Smooth curve when you join. Okay. Continuous function. This function is continuous. There is no cut in the function, no jump, nothing. So the second graph, just plot the points as in the first one. Negative 2, you cannot plot this point because it goes to 9. Negative 1, 3 on the y-axis, that's your point. And then 0, 1, 0 on the x, 1 on the y. Okay, that's your 0 on the x. And then 1 and 0.3 and 2 and 0.1, join them and you get your graph. Make sure you join with a smooth curve that doesn't break, doesn't cut, okay, like that. That's it. Thank you and see you soon with more videos.